All right, at this point, we have worked every area equation on the GED formula sheet except for trapezoids. And that's because they have some parentheses, they have a fraction, they look kind of intimidating. And so in this video, we're going to break down the area of a trapezoid formula, and you'll see they're really not that bad once you understand what these problems actually require you to do. So remembering from the green videos that a trapezoid is basically a triangle with its roof sort of cut off. You can imagine that was a triangle and the top was cut away. So now we're stuck with this sort of base of what used to be a triangle. There's a lot of numbers going on here. So let's unpack the formula and see what information we do need and what information we do not need. If you remember from triangles, we see this little h in both parallelograms and in triangle problems. And you might remember that little h stands for height of a shape, the vertical height specifically, which means it's not a diagonal height. So when we see this 5 and this 4 over here, it can be tempting to make the mistake of thinking that 5 is the height or 4 is the height. But a height is always going to be the straight up and down distance from the bottom of a shape to the top of a shape. If you remember from triangles, this came up a lot. So remember that little h means the vertical height. And you see there's a dotted line here. It's dotted to show you that it's not actually part of the shape. It's not something we would count if we were counting the perimeter, right? If we were going around this whole trapezoid, we would need the 10 and the 5 and the 6 and the 4 and add them all together. This 3 is sort of just measuring. If we had a tape measure to see, okay, how far is the top from the bottom, we'd find that it is 3 feet, not 4 or 5 feet, since those are diagonal measurements. Okay, so that's the first order of business. That little h is going to be a 3. So first I'll write out the formula for you so you can see what's going on. Remember from our golden rules too, you need to write out the formula without doing any math. Just write out what you're dealing with. Even if you don't understand all the pieces yet, we're just writing it down. And so now that we know this 3 is h, I can see right here, here's my h. So I'm going to replace that when I rewrite this. I'm going to replace that with a 3. The 1/2 is given to me. I'm going to put the 3 in parentheses just to remember that it's multiplication. And then I have this other parenthesis set of b1 plus b2. Okay, what is b1 plus b2? Again, looking at triangles and parallelograms at the formulas on our formula sheet, we had little b before, and you might remember what that stands for. It stands for the base or the bottom. Okay, so in this case, we have a B1 and a B2. Well, what does that mean? Well, it's safe to assume that this 10 is the bottom, so that's a base. And so I'm going to go ahead and fill that in for B1. I'm just going to know that this B1 from the formula is the bottom of the trapezoid. But we also have B2. And that's because if we were to flip this thing upside down, what would become the bottom? This line would become the bottom. And so if you think about the base, the bottom base and sort of the top base, either one could hold the trapezoid up. If you were to flip this thing over and you wanted it to stand up on its own, it would still stand up on its own. It would look kind of like a lopsided bowl if we did that. The way it is now, it's a triangle with the top cut off. So 10 could be the base, or if we flip it over, 6 could also be the base, because these lines are parallel, right? These two lines are running in the same direction. The 4 and the 5 can't be bases because really they're not parallel, and it would be awkward to stand the trapezoid up on those sides. It might stand, but it's not very balanced. So what's the most balanced way? And thinking of the word balance, you could also think of little b, because the word balanced starts with b. So that's one way to think about it. If you can remember that the two bases are the lines that run in the exact same direction, meaning they are parallel, that's one of the words we learned in the green videos, then you can remember that those two side lengths are what we put in for B1 and B2. So it's going to be 10 and 6 in this case. okay? So you see, I haven't done any math yet. All I've done is replace the letters that were given to me, the ones that I know, with the numbers given to me in the problem. I know that the straight up and down line is my height, and the two parallel lines for the base 1 and base 2 are B1 and B2, and I'm just replacing the letters. Okay, so now if you are a straightforward formula person, you have everything you need to enter this problem into the calculator. If you want to understand a little bit more about what happens first, this is where we get into PEMDAS. We've covered PEMDAS in the algebra course, but since we haven't covered it in the geometry course, I'm going to break down what PEMDAS is before we move on in this problem. So we're going to take a little break from the problem, and I'm just going to give you a new concept here. If you already know what PEMDAS is, you can kind of skip forward through this part because you already know that the first part of the problem that we were working on is going to be to address the parentheses. If you don't know that, you have no idea what I'm talking about, then stick with me and we'll get through PEMDAS so that this makes sense. So PEMDAS is an acronym, which means every letter stands for a word, and it tells you the order in which you need to conduct every math problem if there's more than one type of operation. Almost all the formulas we've seen so far are just straight across multiplication, maybe squaring something. And so they're pretty straightforward. There's no question about what to do first once you have the numbers written out. So when we did area of circles in the last video, it's pi r squared. So you put in pi, you multiply that times a radius, which you square, you put it all in the calculator, and the calculator knows what to do with that. If you have multiple steps, like in this problem, we have a parenthesis set with some addition inside, and we have some multiplication, we have a fraction, there's a lot going on. So the order of operations says that anytime we have something inside parentheses, like in this question, 10 plus 6, because it's happening inside these brackets, right? Inside these curvy lines are called parentheses. And that's why the first letter is P. It stands for parentheses, meaning that if you have parentheses in a problem with numbers inside that you can simplify, you have to do that first. You have to do that first. Now, in our problem up here, you see that the parentheses are way out here on the right side. And if we were reading, we always read from left to right in English. So it's kind of counterintuitive. It goes against our natural thought to think about doing 10 plus 6 first when it shows up last in the problem. And that's why PEMDAS exists. PEMDAS tells you that you don't always go from left to right in math. You have to follow the order of operations. You have to follow PEMDAS, which means you deal with parentheses first, no matter where they appear in the problem. Okay, E stands for exponents. So for example, when we saw pi r squared, right? We saw like pi 5 squared. There is multiplication happening in between the 5 and the pi. But if you were doing this the longhand, you wouldn't do pi times 5 and then square that answer. You have to do the 5 squared and then it multiplies by pi. Your calculator knows to do that. That's why you're getting the right answers and why we didn't talk about this in the last video. So for now, just understand that exponents are when you have a little number up above like that. So first you deal with parentheses, then you deal with any exponents, which are the little numbers that show up above big numbers. M is for multiply or times. So I'll just write that out, times, because now you're probably used to not seeing the X for times, so multiplication. D is for divide. A is for add, and S is for subtract. And there's a couple little nuances here. M and D can be flip-flopped. Adding and subtraction can be flip-flopped. We're not going to have to deal with those little exceptions to the rules in this problem, but as we see them in other problems, I will show you how to use PEMDAS to figure stuff out. So for this problem, what operations do we actually have in play here? Well, we definitely have parentheses. That's why I put those in 10 plus 6. We don't have any exponents. There's no little numbers above big numbers, so we can ignore the exponents rule. We definitely have a lot of multiplication. happening, right? We have multiplication happening here and here. So we have a little multiplication, which needs to happen after we deal with the parenthesis set. There's no addition, there's no division, there's no subtraction, unless you count the division happening in 1/2. Similar to how we dealt with triangles, we can either divide by 2 at the end or we can multiply by half. I'll show you what that looks like when we actually do the math. So for now, we see that we need to deal with our parentheses first, which means we need to do 10 plus 6 as our first mathematical step. So if you're not using a calculator and you want to see this the long way, and I'll show you how to punch it all in the calculator too, so you can see it both ways. But for now, I'm going to walk you through the math the long way so that you understand why the formula is what it is. I'm going to rewrite 1/2 times 3. And now, instead of 10 plus 6 in parentheses, I know that 10 plus 6 is 16. So I'm going to put 16 there because that is what 10 plus 6 is. And now I don't have any operations inside a parenthesis set. Now all I have left is multiplication. So I can do 1/2 times 3 times 16. I can punch all of that in the calculator. So let me scroll back up here so we can see the calculator and know what to do. So to do 1/2 times 3 times 16, you can punch this in a couple different ways. We can turn a half into a decimal. If you automatically already know that a half is the same thing as 0.5, you can punch in 0.5 times 3 times again 16, enter. And you will get an answer that way, and you see that it's going to be 24. If you don't automatically know that a half is 0.5, that's okay. Erased my parenthesis there. You can also punch in 1/2 with the calculator, which we have done before when we did triangles. You start a fraction to clear out your calculator completely, and then you're going to start with this n/d button that looks like a fraction with an n on top and a d on the bottom. That's going to open an empty fraction for you, and it'll blink above the space. Our fraction is a half, so we're going to put a 1 on top. We're going to use the scrolly wheel, the bottom arrow on the scrolly wheel, to go underneath the fraction, put the 2 on the bottom, and then hit the right arrow on the scrolly wheel to wheel out from underneath the fraction. So now you should have 1/2, and the blinky cursor should be out to the right of the fraction. Now you can hit times 3. So we got times 3, and then times again. And you're going to punch in 16 and enter, and you get 24, just the same way you did if you used 0.5. The third way that you can do this, say, oh my God, I hate fractions. I don't want to deal with a fraction. I don't know what to do. If you remember from triangles, multiplying by half is the same thing as dividing by 2. So if at the very end you prefer to just do, I'm going to rewrite it like this. You can also look at this problem like this, 3 times 16 over 2. That's the same exact thing. Dividing by 2 at the end is the same thing as multiplying by a half. And you can divide by 2 at any point. It doesn't matter. That's what I mean by the multiplication and division can be switched. It doesn't matter if you divide first or multiply first, divide at the end, you'll get the same thing. So give that a try. Clear out your calculator and punch in 3 times 16 divided by 2. And you can do 3 times 16, enter to get 48, and then divide by 2, or you can put it all on one line. 3 times 16 divided by 2, all on one line together, and you still get 24. If you were to switch up the order and do 3 divided by 2 times 16, you will still get 24. Or if you do 16 divided by 2 times 3 equals 24. Because in PEMDAS, you can switch multiplication and division. That's why you get the same answer no matter the order that you do those steps in. So no matter how you cut down this trapezoid, the area is going to be 24 square feet. And that is how you break down a trapezoid problem. The key here, there's a couple things. Make sure the height is the vertical height, the distance between base 1 and base 2, and make sure your base 1 and base 2 are the parallel lines. So in this case, it was the 10 and the 6 because those two lines run in the same direction. Also, very important, make sure when you go to do the math, you're dealing with what's in the parentheses as your very first step. You have to get that addition done first because it is nestled in parentheses, and PEMDAS says you must do parentheses first. Let's try another one. Okay, so first up, what shape are we dealing with? We're dealing with a trapezoid. What's our formula? This big, ugly, nasty thing right here that's really not so hard once we understand. So let's fill in what we know. Area equals, half is given to us. The height, little h, is it 4? Is it 5? This wouldn't be a 4 over here, but it's okay, it doesn't matter. This is the number we're looking for height. Go ahead and stick that in parentheses so that we remember we are multiplying. Open the bases, parentheses, and let's figure out what base 1 is. Remember that we're looking for parallel lines. So this line are our bases, which means we've got 12 plus 8. By the way, it doesn't matter if you put 8 as base 1 and 12 as base 2. If you were to reverse the order of these numbers and put 8 plus 12, you get the same thing anyway. So it doesn't matter the order. It doesn't matter which one is base 1 and base 2. It does matter that you pick the 12 and the 8 and not the 5 or the 4 or some other number that they give you. We want to use base 1 and base 2. Now, the first step for the math is the parentheses, this part. So first we're going to add 8 plus 12, which gives us 20. So I'm going to rewrite that as a 20. Keep the parentheses there strictly because we need to remember that multiplication is what we're going to do. Why I'm writing this backwards, but there you go. So area is equal to half times 4 times 20. And now we can just punch all that into the calculator. Half of 4, I know right away, is 2. I'll write this out for you. I shouldn't do that in my head. Punch in either 0.5 or 1/2 or save it for the end. Whichever of the 3 methods you prefer is fine. I'm going to go ahead and just simplify. I'll say we'll do 4. I'll write it the third way because I like to divide by 2 at the end. That's just my preference, but you can pick any of the ones that get you to the right answer. It really doesn't matter. So if we do 4 times 20 and divide that by 2, 4 times 20 is 80, which when you divide by 2 is 40. And because it's an area problem, we need square feet, and that would be our answer. I'll show you one more before you move on, but if you've got it, that's really all there is to this video is area of trapezoid. So if you got that with no problem and it makes sense, you could probably skip the rest of this video and move on, but I'll show you one more example in case you want to see one more example. All right, one more here. So we've got area is equal to 1/2 the height, which in this example is 7, times the bases, which is going to be 9 plus 6. So first step is to add inside the parentheses. 9 plus 6 is 15. Area equals 1/2 times 7 times 15. Go ahead and punch that in the calculator. I like to do the 7 times 15 and then divide by 2. And in this one, you actually end up with a decimal, which is fine. Don't let that scare you away. Whenever you're cutting stuff in half, you have the potential to end up with a decimal because obviously if you have an odd number, 7 times 15 is 105. When you cut that in half, you're not going to get a whole number because it's not an even number. So you end up with 52.5. And sometimes you're going to get decimal answers, and that's absolutely fine. We're still dealing with feet, so square feet would be the answer here. So that is how you calculate area of a trapezoid.